Okay, so moving on to the next video, which is all about dividing polynomials. Now, a polynomial is actually a finite number of terms in an expression where all the indices are positive integers. So for example, this one here, this and this one here, they're both defined as polynomials. And what we're going to do now is go ahead and divide. This method is very useful because it allows us to find linear factors and therefore factorize terms which have a higher power than 2. So we know how to factorize quadratics, right? This allows us to factorize cubic functions or even quartic functions. Right, so let's go ahead and look at how to divide polynomials. So let's look at this example here. Right, before we even start, I want to give you like a tip. So if you have to write or encounter an x squared or like an x cubed value, make sure you write it in the appropriate column. So if an x squared value will be in the x squared column. So same thing with the x cubed or like an x term or even like a number term. They all go in their respective columns. Right, the way we go about doing it is just a series of steps. So first things first, what I do here is I divide the first term in the polynomial, x cubed in this case, by this value here, this x. So x cubed over x, I get x squared, which I'm going to write on the top here in the x squared column, because it's an x squared term. So I'm going to write x squared here. The next step is now multiply this x squared with each of the two values in here. So I'm going to multiply it with x, I get x cubed, and I'm going to multiply it with minus 5, I get minus 5x squared, which I'm going to write underneath like so. I'm going to put this in brackets and then subtract it. And what I do now is I subtract the top to the bottom. So you can see now the x cubed terms will disappear. I'll get minus 8x squared minus minus 5x squared, which is minus 3x squared, which I write here. That's basically one, I call it iteration, one step. And what we're going to do is now repeat this iteration. So the next step, I bring down the next term. So I'm going to bring down this 13x like so. And what I do now is I divide this minus 3x squared with the original x. I get minus 3x, which I write on the top in the x column, so here. And then I multiply this minus 3x to each of the two terms. I get minus 3x squared plus 15x. I put them all in brackets and subtract. You could see that the x squared terms disappear now, and I'll be left with 13x minus 15x minus 2x, which I'll write down here, which is the second iteration. Let's do it one more time. So next I bring the 10 down, so I have minus 2x plus 10. I divide this minus 2x by this x, so I get minus 2, which I write on top in the number column like so. I multiply this back into the two terms, so I get minus 2x plus 10, put them in brackets and subtract, and you notice that we get a value of 0. What we've essentially done is finish the algebraic division. And so what this means is it tells us that x minus 5 is a linear factor of this original polynomial because of the fact that we get 0. This 0 is a remainder. If we get a remainder which is not 0, anything else, then we can conclude that this original term here was not a factor. So this term here is called the remainder. The term at the top is called the quotient. So what we can now say is if I had the function of f of x is the original polynomial, I can rewrite it as x minus 5 times the quotient. So x squared minus 3x minus 2, which you can factorize further on. So this is basically algebraic division. It allows us to find linear factors of polynomials. So the process itself is just repetitive. It's just getting used to the steps, making sure you follow the correct steps and keep repeating until you get the remainder. However, there are a couple of weird questions that they could give you. So for example, this one here. At first glance, it might seem the same. However, there is one important term that's missing. So we have minus 3x cubed plus 50x minus 8. You can see there's no actual x squared term. So if I was to start doing long division, what I have to put in is actually an x squared term, and we do that by writing 0x squared like so. This is a very, very crucial step that we need to add in. You can't forget this step here. So if I had this example here, we had like x cubed minus 1 over x minus 1. If I write the long division out, I have x minus 1 and I'll divide it. You can see there's no x squared term and there's no x term either. So I have to just say x cubed plus 0x squared plus 0x minus 1 and then go ahead and do the long division. So this is very, very important when it comes to long division or algebraic division. You have to include these terms if they are missing from the original polynomial. Anyway, let's go back to the original one. So let's go to this one here and let's go ahead and divide. So let's follow the same steps. Remember, first thing was divide this minus 3x cubed with this initial x, which I get minus 3x squared. I write it on top in the quotient area and I write it in the x squared column like so. I now multiply this back into the two values, so I get minus 3x cubed plus 12x squared, which I put in brackets and subtract. I'll leave the x cubed terms disappear, I'll be left with minus 12x squared, bring the 50x down, and then repeat. So minus 12x squared divided by x, minus 12x, right in the quotient place, times that back So I get minus 12x squared plus 48x, put them in brackets and subtract. I'll be left with 2x, bring the minus 8 down, and then repeat. So 2x divided by x is just plus 2, right in the appropriate area. 2 times x minus 4 is 2x minus 8, which I subtract, and I get 0. So I got a remainder of 0, which tells me that x minus 4 is a linear factor of the original polynomial. And so I can rewrite the original polynomial as such, like this. So go ahead and practice some of the questions that I have highlighted after the video. It's the same process, so as long as you remember, write the appropriate terms in their appropriate columns, and make sure you include the missing terms in the original polynomial. Then you can solve any question that they give you in the exam.